The following table contains the number of successes and failures for 3 categories of a variable. We want to test whether the proportions are equal for each category at the 1% level of significance. Before doing so, we can write out our hypothesis test. So in this case, let me put this in a marker. The null hypothesis. The null hypothesis is that the variables are independent. So the 2 variables are independent. The alternative is that the 2 variables are associated, or not independent. Meaning, to use what they have on here about the proportions being equal, the null hypothesis would be that they are not equal, while the alternative is that they are equal. This uses a degree of freedom, and let me write that. I'll put that up here. The degree of freedom, we have 2 rows, so if we subtract 1 from that, we get 1, times, we have 3 columns. Again, we subtract 1 from that, we get 2. So degree of freedom for this test is 2. But let me very quickly enter this data into my template here on the right. So we have a 76, 84, 69, 44, 41, and 49. In the expected column, expected tab, we have these column totals, the expected results. The part that we care for this test would be on, we have a degree of freedom here of 2, which we already said. The chi-squared test statistic is 1.99. So chi-squared is 1.99. Likewise, the p-value here, 0.3699. And we want to compare that to our level of significance. But a level of significance of 1%, well, 1% is a lot less than this p-value. So now we can write our conclusion from this test. So this would be, at the 1% level of significance, we do not, since again p-value is much greater than the level of significance, we do not have enough evidence to suggest that the variables are associated. Or to put it another way, we do not have evidence to suggest that the variables, that the proportions, are equal. In order to put into words of what the question itself was asking.